Today is 1st of January 2025. About definition of limit of function and continuity of function, and also how the abstraction and specification is working in real analysis and for entire mathematics. We will see one by one. First, limit of a function is let subset E, which is subset of real number, and this will be not a zero set. And let's make a function which is from E to real number. Then we can make T, which is limit point of E. Then we will say function value fx converges to L. This is the notation when x goes to P, limit fx equals to L, which is if we use epsilon delta, then it will be delta exists for every epsilon if x is element of E and the distance between x minus P is smaller than delta, then distance between fx and L is smaller than epsilon, then we say fx converges to L. Continuity of function is also similar. Just check, replace L to fp, then when there's delta exists for every epsilon and x is in E, when x minus p is smaller than delta and fx minus fp is smaller than epsilon, then we will say function is continuous. And this is very important question, which is why we use epsilon and delta. When we do mathematics, the very important thing is universality and objectiveness. Universality is the belief of which is epsilon and delta will be used for not in R1, but also in R2 and other topological space. Let's say if we see here, this limit of function and continuity can be used for in various of area, which is in name of convergence in L2, L1 probability and measure theory, this kind of thing. And this is actually central limit theorem. This central limit theorem is actually, if you go down deeper, this is just epsilon. We can specify it by epsilon and delta. For some delta, there's delta for every epsilon, then there will be x, which is in set E, then there will be some x minus p, then which is smaller than delta, then there will be some fx minus fp, which is smaller than E, then we will say this is converse and continuous. Then this is used in central limit theorem, also in L2, L1, and probability and measure theory. The intuition, what we should get is, we should see the other phenomenon in this epsilon and delta level. So this limit of sequences related with supremum, and also which is also related with lift upper bound and Archimedean property, which is real numbers property. Archimedean property is it will be equal even you just set epsilon as 1 over n or other value, the information quantity will be equal. A lift upper bound is you can set any, you can grab any real number. So the exercise, what you can do is you can change the definition of primum with property of real number or property of real number to definition of primum. After this flow, you can map every primum to real numbers property. And after that, you'll be able to, we will study the definition of determinant and group theories, normal subgroup with equivalence and equivalence relation and quotient concept. Then we can go more deeper math and we can repetitively learn mathematics with its core concept. Thank you very much today.